Okay, when we finished on the last video, we were about right here on number 7. So we were talking about our definition of a derivative that looks like this. And so what I want to do is I'd like to find out what f of x is based off of the information that I'm given here. So if you look at your definition of a derivative, you'll notice that I've got f of x in the same place that I have the tangent value. The f over here also the same place where I have tangent. So I'm going to say that f of x is the tangent of x. And then I want to find the derivative of that where x is equal to what x is equal to in my formula up here, which x here and x here, both at pi over 4. So that's what I'd like to find is the derivative of f at pi over 4. All right, so my derivative of tangent is secant squared. And then I want to find that derivative at pi over 4. Okay, so we talked a little bit about how we can rewrite secant squared as the secant of x squared, except now we know that x is pi over 4. Okay, so I know my cosine value at pi over 4 is the square root of 2 over 2. So my secant of pi over 4, I'm just going to flip that upside down. And you can rationalize that denominator if you want to, or really you don't have to because we're just going to plug it in and square it anyways. You'll come out with the same answer either way. So I'm going to have 2 over the square root of 2 squared. So when I square the top, I get 4, and when I square the bottom, I get 2, and altogether that gives me 2. All right, on the next section, we start to talk about derivatives. So let me go over a couple of rules with derivatives real quickly. And the first one that I want to go over is the quotient rule. Trying to decide if we should do quotient rule or product rule first. I don't really guess it matters. But if we're dividing f of x by g of x, then my formula for the quotient rule is g f prime minus f g prime all over g squared. Okay, and with the quotient rule, it's very important that it does go in that order. If you're working with a power rule, it's not so important that it go in that order. Let's talk about not a power rule, a product rule. All right, let's talk about our product rule for just a second. So my product rule, if I have f of x times g of x, I'm going to keep it just the same way that I have it up here. I want to find the derivative of that is going to be g times f prime, but now plus f, and then g prime. And the reason why I put them in that order is because now it matches up with this one right here. Okay, so that's my derivative of all of that. Okay, the other rules that I would like to go over is the derivative of e to the u. So we talked a little bit about e. So the derivative of that is e to the u times u prime. And the derivative of the natural log of u is u prime over u. And the derivative of a to the u, so if you had something like 2 to the x power, that would be a to the u times u prime times the natural log of a. So you'll notice that these formulas look very similar. And then the derivative of bases other than e, so that's going to be the log base a of u. So any other base than e that you would have right here is still going to be u prime over u, but then we need to multiply by the natural log of a down there. So those are really the derivative formulas that you'll need to know for the test, along with the power rule and the chain rule, which we're a little bit more used to using. All right, so on number 8, I want to find the derivative of f of x, and they've given me that f of x is 3x to the 4th plus 2 over x, which I'm going to rewrite as 2 times x to the negative 1 power, minus 8 times x to the 3/4 power, minus 5. So now with this being the way that it is with the negative exponent, I can use the power rule on all of these things. Okay, so my power rule tells me to move my 4 to the front and multiply, so that's going to be 12. I'm going to subtract 1, gives me x cubed. Then again, multiply negative 1 times 2 gives me minus 2. And when I subtract 1, I get a negative 2 power. And here, when I multiply 8 times 3/4, I know that 4 goes into 8 2 times, and 2 times 3 gives me 6x, and then I need to subtract 1 from here. So 3/4 minus 4/4 would give me negative 1/4, and then the derivative of the 5 would give me 0. And so if we want to, we can write that in a little bit more simplified fashion. I would make that minus 2 over x squared, and then I would write minus 6 over, and this is going to be the 4th root of x, and then I don't really need the minus 0. That right there is going to be my answer. Okay, on number 9, we get into our first rule about e to the u. So on number 9, they've given me that f of x is e to the sine of x squared power. Right, so I'm going to let u represent the sine of x squared, and now I also have a chain rule. So the derivative of sine is cosine. I'm going to keep my x squared exactly the way that it is, and with my chain rule, now I'm going to take the derivative of the inside, which will give me 2x. So u prime will be 2x times the cosine of x squared. Okay, so my formula for this is e to the u times u prime. So my derivative is then going to be e to the u, so u doesn't change, and then times u prime, which is 2x times the cosine of x squared. And that right there is a perfectly fine answer. There's not really anything that we need to do to simplify that. Okay, on number 10, we've got two things that are being multiplied together here. That tells me that I know I'm going to be using my product rule. Here they are right here. So this is going to be f, and this is going to be g. And in g, I also have a chain rule. Okay, so f is going to be 3x squared. That tells me f prime then is 6x. And g is going to be the cosine of 5x. And watch my chain rule here. G prime, the derivative of cosine is going to be negative sine. I'm going to keep my 5x the way that it is, and then I'm going to multiply by the derivative of 5x, which is 5. All right, so using my product rule, I'm going to have g times f prime, 6x, plus f, and then g prime, I'm going to go ahead and move that 5 up to the front, so times negative 5 times the sine of 5x. I almost ran out of room there. That's kind of my scratch work over there on the side. Okay, I'm going to do just a little bit of putting some of that stuff together just to make it look a little bit neater. So I'm going to have 6x times the cosine of 5x. And then I'm going to have minus, because my positive times my negative would be a negative, 15x squared times the sine of 5x. Okay, on number 11, we have the derivative of our natural log. All right, so my derivative of my natural log of u is u prime over u. So I'm going to let u represent x cubed plus the tangent of x. Therefore, u prime will be 3x squared plus, and the derivative of tangent is secant squared x, and if I use my chain rule, the derivative of x is just 1. So times 1, we don't really need to write on there. Okay, so my derivative then, I'm going to take my u prime that we just found, 3x squared, plus the secant squared of x over u, which is x cubed, plus tangent x. And nothing will cancel out with that one, so that right there is my answer. I don't want to take out an x because this x is tied to this secant, or this x is tied to this tangent. They are angles, not just numbers, so you don't want to try to cancel those out. Okay, on number 12, you can either treat this one as a quotient rule, or you can move the x cubed up to the top and use a product rule. I'm going to go ahead and just use a quotient rule. So I'm going to say in my scratch work over here that f is the tangent of x, therefore f prime is secant squared, and g is x cubed, therefore g prime is going to be 3x squared. Okay, so the numerator is always f and the denominator is always g. Alright, so my formula tells me to do g f prime minus f g prime all over g, which is x cubed squared. I want to multiply those exponents together, so that will give me x to the 6th. And that right there again is going to be my answer. You can take out a common factor of x squared and cancel out with the x to the 6th if you want to, but that right there is a perfectly fine answer. Okay, on number 13, we have our a to the u situation. Okay, so on 13, we're going to have f of x be 3 to the sine x power. So a is going to be 3 and u is going to be the sine of x. So if you ever have an integer here being raised to some kind of exponent with an x in it, this is when we want to use the a's and the u's. And I need my derivative of u, which is the cosine of x. So my formula tells me to do a to the u times u prime times the natural log of a. And I'm just going to fill that in. So 3 to the sine x power times the cosine of x times the natural log of 3. And there's my answer for f prime. I should label that f prime right there. Okay, on 14 we have a very good example of a chain rule problem. 2x cubed plus 5 to the 4th power. So I've got something on the outside of something else. So let's start with the outside piece. I'm going to bring that 4 to the front. I'm going to keep this exactly the way that it is. And then I'm going to multiply by the derivative of what's in here. So then here I've got 3 times 2 gives me 6x squared. And then I've got plus the derivative of 5, which is just 0. So really I could go ahead and multiply my 4 and my 6 together right there. That'll give me 24x squared. And then I've got 2x cubed plus 5 cubed. Okay, and the last one for this section, we're looking at a logarithm with a different base on this one. So again, I want to use some a's and u's. Right, so a is going to be 3. U is going to be x squared plus 5x, and I'm going to need the derivative of u, which is 2x plus 5. So taking the derivative of that right there. Okay, so my formula for this tells me to do u prime over u times the natural log of a. So u prime is 2x plus 5, and I'm going to divide by x squared plus 5x. I need some parentheses around that so that if we were going to work it out, we would distribute our natural log of a, which is 3. And there's y prime right there. And again, that right there is a perfectly fine answer. Okay, on the next video, we'll pick up with number 16.